Well, now we are going to start with the concepts of the nuclear physics. Now, our main discussion will be towards the nucleus. What is the order of size of the nucleus? That is the order of nuclear radius, the nuclear density, then different type of nuclei, and other thing will be that is what are the standard units for the surface area of the nucleus and the volume. Now, in the nuclear physics, basically, we have to go through with the formula of the nuclear radius. The basic formula for the nuclear radius was first explained by Rutherford by performing the scattering experiment, that is the gold foil alpha scattering experiment. And that formula has proved that the center of the atom, that is the nucleus, has net positive charge, and the nucleus is made up of protons, and the number of protons provide the atomic number. And after that, we have gone through with the Bohr's formula of the nuclear radius. However, you can also remember that Bohr has suggested the formulas for the atomic radius also, that is the radius of the orbit of electron or radius of the permitted shell of electron. So there will be distinction in the two things. One is the Bohr's formula of nuclear radius and other is atomic radius. But we will limit our studies to the nuclear radius. So according to Rutherford, the formula of nuclear radius is 4k Ze square over m alpha v alpha square, where k is electrical constant, 1 over 4 pi epsilon naught, and its value is 9 into 10 to the power 9. And other thing is that is about 4k Ze square, where Z is atomic number or the number of protons constituting the nucleus. E stands for the charge of each proton. In the denominator, normally we write m alpha v alpha. So m alpha stands for the mass of alpha particle, and v alpha square, that is v alpha stands for the velocity with which alpha particle is moving towards the gold foil. So m alpha and v alpha are the standards for the alpha particle. Alpha particle is a helium nucleus. So when alpha particle moves towards the gold foil, first of all, we recover alpha particles from a radioactive source, especially radium or polonium, and then through a narrow slit, they move in the form of a parallel beam towards the gold foil. And when they strike the gold foil, we assume that gold foil is made up of many atoms. Alpha particle enter the atom and gets scattered in the different directions. And some components of alpha particle retrace the path after entering the atom. That is from nearby the nucleus or the center, they are reflected back. So these all facts are utilized for calculating the radius of the nucleus, which is found to be 4k Ze square over m alpha v alpha square. And this number can be modified to that is 2k Ze square over half m alpha v alpha square. That is equal to 2k Ze square over kinetic energy of alpha particle. So radius will be directly proportional to atomic number or the number of protons constituting the layer, constituting the nucleus. R is proportional to Z. But in this formula, there is a drawback that this formula only explains the nuclear radius for those nuclei which are constituted of protons only. In this formula, the number of neutrons were not considered. So the formula has been modified by Bohr and suggested that nuclear radius can be estimated by formula, that is R is equal to R naught a to the power minus a to the power 1 over 3. R naught means the nuclear constant and simply R means the nuclear radius, and nuclear radius is found to be proportional to a to the power 1 by 3, where a stands for nucleon number or the atomic mass number, that is proton plus neutron number. So this formula gives the accurate results for the nuclear radius. Now we come towards the main concept, that is Rutherford scattering experiment established that the mass of an atom is concentrated within the small positively charged region at the center, and this region is called the nucleus. That is, nucleus is constituted of protons. The net mass of the atom is concentrated at the center. The radius of nucleus, that is R, that is given by composition R naught A to the power 1 over 3. A stands for mass number, or the nucleon number, that is P plus N number, and R is proportional to A to the power 1 over 3. R naught is supposed to be the nuclear constant, and its value is nearly 1.45 Fermi, or 1.45 into 10 to the power minus 15 meters. However, its minimum value can be taken as 1.2 Fermi, that is 1.2 into 10 to the power minus 15 meters. So this value varies generally from 1.2 to 1.4. So we can take 1.45 Fermi. And the volume of the nucleus, we assume that nucleus is supposed to be a solid sphere constituted of protons and neutrons. So volume of nucleus is calculated by the formula, that is 4 pi r cube. So it is 4 over 3 pi r cube. So 4 over 3 pi, and for r cube we can compute r naught cube, and a to the power 1 by 3 will be taken as a cube. So our net formula will become r naught a, that is for r cube. And it will be estimated that volume of nucleus is directly proportional to the nucleon number. If the nucleon number is more, that is proton plus neutron number is more, the volume will be more. Well, the next concept is examples based on the radius of nucleus. The ratio of the radii of nuclei, that is 31 aluminium 27, and another one is 52 tellurium 125, is approximately. Well, I think we have to take into consideration the mass numbers. So aluminium mass number is 27, and for tellurium it is 125. We know that 27 is a cube of 3 and 125 is a cube of 5. So we find that radius of aluminium nucleus to the radius of tellurium nucleus, 27 to the power 1 by 3 over 125 to the power 1 by 3, and this comes to be 3 over 5. That is 6 over 10, and finally it becomes 3 over 5. So next is the radius of 30 Zn64 nucleus is in Fermi. So now we will find the radius by formula R naught A to the power 1 by 3. Whatever radius we find in meters, we divide it by 10 to the power minus 15, and answer will come in Fermi. So the formula applied is again the same, R naught A to the power 1 by 3, and R naught is nuclear constant, that is taken as 1.2 Fermi. So 1.2, 10 to the power minus 15, and for A we will put 64 cube, and that will become 4. So 4 is multiplied by 1.2, 10 to the power minus 15, and first of all we get our answer in meters, and then we convert it to Fermi, and finally it will become 4.8 Fermi. So we find that A is directly proportional to R cube. A means the nucleon number or the mass number or the proton plus neutron number. X is supposed to be the element, A is the mass number, and Z is atomic number. The nucleus is generally represented by ZXA, or the alternative method of representation, that is also ZXA, but A and Z will be shifted toward the left index and bottom corners. Number of neutrons will be A minus Z, mass number will be A is equal to P plus N, A is equal to P plus N, or A is equal to Z plus N. 1 AMU is 1/12 the mass or 12 grams of 6C12. So 1 AMU is found to be 1.66 10 to the power minus 27 kilograms, or 1.66 10 to the power minus 24 grams. Now our question is how many electrons, protons and neutrons are there in a nucleus of atomic number 11 and mass number 24. So this seems to be an isotope of sodium, because atomic number for sodium is 11 and mass number is 23, but it is mentioned 24 here, so it is supposed to be an isotope of sodium. So electron number and proton number remains the same, and neutron number will be, that is atomic mass number minus atomic number. So the number of electrons and protons will be 11 because 11 is the atomic number, and from 24 if we subtract 11, that will become the number of neutrons, so they are found to be 13. So number of protons in nucleus, that is atomic number, that is 11. Number of electrons will be equal to number of protons, that is 11. Number of neutrons equal to mass number A minus atomic number, and it is found to be 13.